Historically, the average height for males was believed to be 68 inches. A doctor believes the average height has increased over the last 100 years. He claims the average male is now 70 inches tall. A random sample of 50 men has an average height of 68.9 inches and a standard deviation of 2.8 inches. Use a 10% significance level and the p-value method to test the doctor's claim. Okay, so in this problem, what we want to do is first identify what technique we should be using. So it says that we want to use the p-value method to test the doctor's claim. So to test the claim tells us that we're dealing with a hypothesis test, and the mention of the p-value method says that we should use that particular approach to do it. All right, so let's try to identify the claim first and foremost. So our first step is to get the claim. So it says test the doctor's claim. Let's see what the doctor says. It says the doctor believes that the average height has increased over the last 100 years. He claims, so there's his claim, that the average is now 70 inches tall. So that means that he's saying the mean is equal to 70. All right, now we'll get from that HO and HA, our competing pair of hypotheses, right? If the claim has an equal sign, it is HO, so we're going to use mean is equal to 70 for HO, and then HA should be the opposite of that, so we'll say the mean is not equal to 70. All right, step 3 is to get the data, so record the data from the problem. All right, for claims that are about the mean, when we test them, we're usually given the information n, x bar, standard deviation, and alpha. Okay, so let's find n for this problem. It says a random sample of 50 men, so n is 50. Then it says they had an average height of 68.9 inches, so x bar is 68.9, and a standard deviation of 2.8 inches, so s is 2.8. That's the standard deviation. Then it says use a 10% significance level. So our alpha here is a full 10%. Okay, once we have that, once we have the data, we plug it into our test stat formula. So step 4 is to get the test stat. Okay, so if it's a hypothesis test about the mean and the sample size is large, we will use the formula z is equal to x bar minus mu sub 0 sigma divided by the square root of n. Okay, for us, when we work this out, x bar is 68.9 minus this value, which comes from HO. Remember the subscript here lets us know that we use that number, so we use 70. Then sigma will be substituted by s, so 2.8, and then divide by the square root of n. The square root of n in this case is the square root of 50. Okay, so we have our test stat filled in. Let's calculate it with our calculators. So 68.9 minus 70 divided by 2.8 divided by the square root of 50. Okay, so we end up with minus 2.7779, so I'll call it minus 2.78. Minus 2.78. Remember, when working with the p-value method, it's important to round your test stat to the hundredth place. In other words, 2 decimal points after the decimal place. Okay, so we have that. Now our next step is to get the p-value, right? So step 5. The difference between the traditional method and the p-value method to a hypothesis test is that in step 5, we do the p-value approach instead of the critical value. So in order to calculate the p-value, I would like you to first draw a bell curve. Okay, now on that bell curve, you should label your test stat where it belongs. Remember, the center is here. The z number line. A negative test stat would end up on this side of the curve. Now the rule here for p-values, we have to identify what kind of hypothesis test we're doing. We look at HA to figure that out. HA indicates here, by using the not equal to symbol, that we're dealing with a two-tailed test. If we're dealing with a two-tailed hypothesis test, the rule to calculate the p-value is to find the tail area after your test stat and then to double it. because it's a two-tailed test, we will double the tail area that we find. Okay, so find the tail area by looking up 2.78 on the z table. So let's go to the z table now and look up our minus 2.78 on that table. Okay, so we're looking at 2.78 on our z table. Let's scroll down till we see the 2.7 row. Okay, so there we are in the 2.7 row, and we have to count over till we get to 8. So 2.7, 0, 1, 2, 3, 4, 5, 6, 7, 8. And the answer is 0.4973. Okay, so we found the answer 0.4973. That's for this area in the white space. We need to find the tail area, so we'll do 0.5 minus that. 0.5 minus 0.4973. And of course, we get the answer 0.0027 in that case. So the p-value is going to be twice that amount, so 2 times 0.0027. Okay, so we can do this in 2 ways. We can either multiply by 2 or we can just add it to itself, right? That'll be doubling it by adding it to itself. So let's do the addition. 7 plus 7, of course, makes 14. That'll give you 5. And then we have the 2 zeros. So the p-value becomes 0.0054 or 0.54%. All right, in step 6, we want to make form our initial conclusion. Okay, so to do our initial conclusion, we want to compare our p-value to our alpha for the p-value method. That's how we do the initial conclusion using the p-value approach. So let's write our p-value down. That was 0.54%. So a very small percent, right? 0.54%. We're going to compare that to 10%, which is our alpha value. Well, in this case, we definitely see that the p-value is far less than alpha. And whenever the p-value is less than alpha, we reject HO. So remember, if p is less than alpha, you reject HO. And if you reject HO, you simultaneously support HA, because that goes hand in hand, right? If you do one, you do the other. All right, so we know that this is our pair of initial conclusions, but the question is, which one will we use for our wording? Are we going to say we reject the claim, or are we going to say we support the claim? Well, to figure that out, we have to go to the claim itself and ask ourselves, which one is this? Is this HO or is this HA? Well, we saw that it was HO, right? So that means we're going to use the wording that's attached to HO, so we're going to say that we reject the claim. So you're going to say the sample data allows us to reject the claim. And this is to reject the claim that the mean is equal to 70 inches, right? So this professor claimed that the average height was now 70 inches for males. Well, based on this sample data, it doesn't seem that that's correct. So we're going to reject that doctor's claim based on the sample data that we collected.